Hello everyone, this is Shalini here. In this video, I will see that comparison of topologies. So what is the comparison of topologies? Let's see. Let xt and xt dash be two topological spaces. If t contained in t dash, then t dash is said to be finer or stronger than t, and t is said to be coarser or weaker than t dash. Right, students? Suppose xt be a topological space and xt dash be another topological space. That is, t and t dash are two topological spaces on X. If t contained in t dash, then t dash is said to be finer or stronger than t, and t is said to be coarser or weaker than t dash. Right? What we say? A is subset of B and B is superset of A. Right? So here, in comparison of topologies, if t contained in t dash, then t dash is said to be finer topology, and if t contained in t dash, then t is said to be coarser or weaker than t dash. Right? If t contained in t dash or t dash contained in t, then t and t dash are said to be comparable. If t contained in t dash or t dash contained in t, then t and t dash are said to be comparable. If t doesn't contain in t dash and t dash doesn't contain in t, then t and t dash are said to be incomparable topologies. Right, students? Now it will be more clear by one example. So what is the example? Example is x equal to abc. X be a non-empty set which is abc. Suppose we define a topology t1 is equal to phi ax, and we define another topology t2 is equal, which is phi a b double turn ab and x. Now from here we can see that t1 all members of t1 is also members of t2, right? But some members of t2 which is not in t1, right? So what can we say? We can say that t1 is contained in t2, that is t1 is subset of t2, right? And what is the definition? Definition is either t1 contained in t dash or t dash is contained in t, right? So here, from here we can see that t1 is contained in t2. This implies that t1 and t2 are comparable, right? Now similarly we define another topology t3 phi b ab x on x, right, students? So in t3 what we see? We see that all members of t3 is also the member of t2, right? But all members of t2 is not the member of t3. So here, from here we can say that t3 is contained in t2. That means t3 is subset of t2, right? So here t3 and t2 are comparable. That means t3 and t2 are comparable. Now t1 is not contained in t3 and t3 is not contained in t1. And one more thing, t3 is not contained in t1. Why? Because in t1 there is an element a singleton a which is not in t3, right? And t3 is also not contained in t1. Why? Because there is one element which is b singleton b which is not in t1, right? So we can say that t3 is not contained in t1, right? So here neither t1 is contained in t3 and nor t3 is contained in t1. This implies that t1 and t3 are not comparable, right? So from here we can see that two topologies which is comparable, that is t1 and t2 are comparable, t3 and t2 are comparable. Why? Because t3 is subset of t2 and here t1 is subset of t2. This means t1 and t2 are comparable and t3 and t2 are comparable. But here we can say that t1 and t3 are not comparable. Why? Because neither t1 does because t3 does not contains t1 and t1 does not contains t3, right? So that is why t1 and t3 are not comparable. So from here some note first. What is note first? Note first is in discrete topology on X is the coarsest topology on X, right? We know that in discrete topology is the smallest topology on X, right? So suppose if we define another topology t on X, that is if t is any topology on X, then t is always greater than I, right? I is always contained in t, right? Because I is the smallest topology on X. So if we define another topology T other than I, this must be superset of I, right? So here, from here we can say that I and T is also comparable because I is always contained in T, where I is in discrete topology. Now second, notice the discrete topology D is the finest topology on X as for any topology T on X, right? We know that students, D is discrete topology, which is largest topology on X, right? So discrete topology is the largest topology on X. If we define another topology T other than D, so we know that T is always subset of D because D is largest topology on X. That means T is always contained in D, right? So always T is contained in D. That means D is largest topology on X. So we can say that T and D is also comparable, right? So here I and T is always comparable and T and D is always comparable topology, we can say, right students? Or students, why we are taking two topologies in comparison of topologies? Students, as we know that comparison is always between two or more pupils or objects, right students? So here at least two topologies must be on X, right? राइट स्टूडेंट्स, तभी हम कंपैरिजन कर सकते हैं, अदरवाइज कंपैरिजन नहीं हो सकता, एक लोगों में कंपैरिजन नहीं होता है, राइट स्टूडेंट्स? सो दैट इज़ द रीज़न ऑफ टेकिंग टू टोपोलॉजीज on X, right students? Two or more topologies can be a pair, right students? So I hope students this lecture is really helpful for you. If you feel my videos are helpful for you, then please mention in comment box in a few words. That's really motivate me. See you soon guys in next video. Till then, bye bye, take care, thanks for watching.